Starting? All right, so another session we have on the RunBMC v1.5 updates. There's Amal, Tariq with me from Meta to share some Meta's experience with RunBMC adoption. Before that, we will go through the overview of RunBMC and I will explain some updates that we are preparing up for the v1.5 specification. So if you look back at the RunBMC specification, it was defined before the DC-SCM. Obviously, this was a standard that was published before the first DC-SCM came up, and there were some adoptions along the way that you can see on the timeline, but those adoptions were tied to those older BMC SoCs, and RunBMC is obviously a BMC SoC on a module, so it really derives from all the BMC capabilities that it hosts, right? So what we are trying to do right now with those RunBMC spec updates is to update the specification so that it supports those new BMC SoCs, and it's also aligned with new platform designs that are also defined by the DC-SCM specs. If you look at the RunBMC, and this is the question we often get, what's the difference between the RunBMC and DC-SCM? So pretty much the RunBMC is the BMC SoC on a SOD module. That's what it is, nothing more than that. So it's a BMC with all the necessary components that you need to have to make this BMC SoC running. While the DC-SCM is exactly the same, plus some additional capabilities like I/O, root of trust solution, the flash devices, and TPM, of course. There are some deployments of 1.41 that you can see publicly, so there's a Hive RunBMC module in the marketplace. There are some open implementations like Intel did with FPGA-based BMC, but this standard is actually being used also in some production systems, and this is what Amal will talk about. So let me hand it over to Amal.
Thanks, Kasper. So my name is Amal. I'm a hardware engineer on Meta's data center network hardware gear. So I wanted to quickly go over where we use RunBMC and why we use RunBMC. So last year at OCP, we shared our 25.6T switching solution, which was our own Minipack 2, as well as Arista's 7388X5 system. And both of these systems in our data center, they can be used interchangeably. And both of them leverage a RunBMC module with ASPEED's AST2620 BMC chip. So the few main benefits for Meta for using RunBMC was, one, that it decoupled the BMC hardware and the rest of the system. If you look at our previous generations of network switching gear, the BMC hardware is soldered down onto larger and oftentimes much more complex PCBs, so any BMC hardware update is tied heavily to a larger PCB respin. The second benefit was modularity. We favor modularity in our system designs, and having the RunBMC module allows us to field replace or upgrade the BMC hardware if needed, and it just generally provides a lot of support for us for enabling or investigating new BMC type technology. Early on during Minipack 2 bring up, actually, we were able to see the benefit of using RunBMC. For us, we were able to borrow RunBMC bring up vehicles from our OCP partners and enable our RunBMC module prior to bringing up the rest of the system, which really let us hit the ground running and is just a general testament to the value of collaboration in OCP. This slide, I'm going to do a quick time check. Okay, I have some time. So this slide goes over our specific Minipack 2 RunBMC, and I want to highlight a few things. we opted for on-module SPI boot flash. So that's one of the scenarios that the spec describes, and we did that so that our BMC module could be relatively self-contained. The other key things that I want to highlight again are we use RunBMC large form factor, and it's mounted orthogonally on our, or with a right angle SODIMM connector on our SMB, which in our Minipack 2 environment, that means the switch main board, which is a very large, it's actually the largest and most complex PCB in Minipack 2. It has a lot of high-speed signal routing, and so being able to have the RunBMC module separate from that SMB really gave us some value in that our BMC changes were not tied to any changes on that SMB. So all of our Minipack 2 hardware and design collateral has been submitted to OCP, and so the RunBMC design collateral is included as part of that. If you're interested in checking out the design information and more details, please feel free to look that up. I'll hand it back to Kasper.
Just a clicker. All right, so we have 1 minute for the v1.5 updates only. So the major objectives are to keep the backward compatibility, because this is not a major update. This is a minor update of the spec, so we just want to update it so that it's usable with new BMC SoC designs. And I'll just walk you quickly through the majority of changes. So we add I3C support, we add DisplayPort support, which was not supported previously. All the dedicated resets that are that found its way into the dedicated pins instead of just GPIOs were being defined here. And this is what we are currently defining in the updated specifications, and we will be posting that out on the wiki so that we go through public reviews, and we are expecting you to provide us with the feedback, review those updates, let us know if there's anything that you wanted to add, to be added to this RunBMC spec update. Thank you.
We actually have time for one question, if anyone has one. If not, I want to thank you for your presentation.
Thank you.